Well, how did your turn turn out? Only had 2 problems. And when I did it, I didn't get either one of them to be a factor. And I tried again because it didn't seem right to me. One of them I thought should be a factor, but I didn't get either one of them to work. So if you have both of those results and you have no question about where the numbers are coming from, then please move on to the assignment. It's only 4 problems. If you do have questions that you don't know how to find out how to apply this theorem, or you did get one of them to be a factor, then please stick with us. We'll work them out. So if the remainder theorem is going to work, it's got to have 2 terms, leading coefficient of 1. We got that. And for the remainder theorem to work, we're then going to put the opposite of what's in here. Substitute that into the polynomial. So if x plus 4 is a factor, a is going to equal negative 4. And that's what we'll put into this polynomial over and over again. So take the 4th power on negative 4, minus 3 times the 3rd power on negative 4, plus 5 times negative 4, minus 27. Well, negative 4 times negative 4 is 16, times another negative 4 is negative 64, times another negative 4 is 256. Minus 3 times negative 4 times negative 4 times negative 4 is a negative 64. And 5 times negative 4 is going to be a negative 20. Well, this negative times negative makes a positive. So we've got 256 plus 192 minus 47. Now you can tell by looking at it that that is not going to come out equal to 0. I believe it does, in fact, come out to 401. Which means if we had divided this into that the long way, there would have been a remainder of 401. Definitely not coming out evenly. X plus 4 is not a factor. So, is x minus 2 a factor? Well, if it is, we'll get a 0 when we put not negative 2, but if we put a equals positive 2 in the polynomial. So we'd have 2 to the 4th minus 3 times cube on 2 plus 5 times 2 minus 27. Well, 2 times 2 is 4, times another 2 is 8, times another 2 is 16. 2 times 2 times 2 is 8. So we'd have negative 3 times 8. And 5 times 2 minus 27. So we have 16, subtract 24, plus 10, minus 27. So we have a positive 26 and a negative 51. So I'm getting negative 25 is the remainder. Once again, this thing is not a factor. If we went to the trouble of doing the long division, we would have negative 25 left over. So it may seem like, why bother? Neither one of them worked. But if our mission was to find factors of some large polynomial like this, at least that eliminates these 2 numbers. We know they can't possibly work. So it may save us from wasting some time. So if you have further questions, please let me know. Otherwise, please go on to the homework assignment And that's the last part for this week.